The probability of occurrence of R events during the specified time interval is given by the Poissons distribution. So when the probability of the event is 0, so the frequency is given as 153. Now if you look into the properties of normal distribution, the value of mean, median, mode are equals. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session, we will be having a discussion on what is Poisson distribution, also working out a few problems on Poisson's distribution. Now let us understand the meaning of the word Poisson distribution. So this theory was developed by a French mathematician, Poisson. So in case P is very small, such that during a specified time period, the average number of occurrences of an event is equal to NP, that is mean or mean. So this Poisson's distribution, this was developed by a French mathematician, Poisson, and here he says that all those occurrences of events which are very small, so very small in number, for that this Poisson distribution will help. Then the probability of occurrence of R events during the specified time interval is given by the Poisson's distribution. So this is for all those statistical data or for all those probabilities where the number is very, very small. So the formula is probability of R equals, so this will be equal to e to the power of minus m into m to the power of r divided by r factorial, where r is the occurrence of the event, that is 0, 1, 2 up to n. So example, now what are the occurrences of this event? So where the statistics are very small. So that is the number of deaths during corona, the number of factory accidents, the number of deaths due to rail or road accidents, the number of deaths due to earthquakes, etc. So where the statistics of the occurrence of the event is very small, for those distributions, we make use of this Poisson distribution. Now, fitting of Poisson distribution and properties of Poisson distribution. For fitting a Poisson's distribution, we must determine the value of mean for the given distribution. Once the mean value is known, the probability of the Poisson distribution can be obtained as x equals 1, 2, 3. So you can substitute the value of x and then find the value of the Poisson's distribution. So P of x equals e to the power of minus m into e to the power of minus m into m to the power of 1 by 1 factorial, then e to the power of minus m into m square by 2 factorial. So the same way, e to the power of minus m to the power of n divided by n factorial, etc. So this is the formula to find out the value of the Poisson's distribution. Now, next, properties of Poisson's distribution. So if the random variable x indicates the number of events occurring in a given interval and it follows the Poisson's distribution with the parameter m, then the following distribution properties are emerged. So if we look into the properties of Poisson's distribution, we have enumerated them here. So the arithmetic mean, that is x bar equals p. Then standard deviation equals root of m, and then we have variance equals, that is when we square this root of m we get m. Then skewness b1 equals m by 1, kurtosis b2 equals 3 plus m by 1. Then next, we'll go to the first problem. It was found that a manufactured product has on an average 2 defects per unit of a product inspected. Find the probability of finding the product without any defect with 3 defects. So this is a problem on Poisson's distribution. So we are having a problem here. It was found that a manufactured product had on an average 2 defects per unit of product inspected. So every product inspected had at least 2 defects. Now find the probability of finding a product without any defect and with 3 defects. So average defect means mean equals 2. Then P of x, we make use of the Poisson's distribution here, that is P of x equals e to the power of minus m into m to the power r divided by r factorial. So, we make use of the formula here, the probability of a product without any defect. So, without any defect means x is equal to 0. So, the occurrence of the defect is 0. So, we substitute the value of x as 0. So, probability of x equals 0 into e to the power of minus m point into 2 to the power of 0 by 0 factorial. So, we know that the value of e to the power of minus m is equal to 0.1353. So, 0.1353 into 1. So, the occurrence of the probability of a product without any defect is 0.1353. So, this is the occurrence of the event. So, this is the chances of having a product without any defect is just 0.13%. Then, the probability of a product with 3 defects. Suppose we have to calculate the probability of a product with 3 defects, then we use the same formula. So, I write here 3 into e to the power of minus m into m to the power of r by r factorial. So, I know the value of e to the power of minus m. So, e to the power of minus m equals 0.1353. So, I write the value of e to the power of m into m to the power r. So, what is m here? M is equal to 2. So, 2, that is the mean is equal to 2. 2 to the power of r is the occurrence of the event. So, 2 to the power of 3 divided by 3 factorial. So, this will be equal to, when I simplify or when I write the value of 2 cube, it comes up to 8. So, 0.1353 into 8. So, this will be divided by 3 into 2 into 1. So, when I just simplify this, I get 0.1804. So, the chances of a product with 3 defects is 0.18. So, almost 20% chance of having a product with 3 defects and almost 13% chances of having a product without any defect. Now, the second one, find the probability that at most 5 defective bolts will be found in a box of 200 bolts. If it is known that 2% of such bolts are expected to be defective. Note, so we find out, we have to work out this problem here. Find the probability that at most 5 defective bolts will be found in a box of 200 bolts. So, out of 200 bolts, they are expecting to find only 5 defective bolts. If it is known that 2% of such bolts are expected to be defective, so they are expecting that 2% of 200, that is 200 into 2 by 100, that is at least 4 bolts will be defective. So, we have to find out the value here. So, the probability that at most 5 defective bolts will be found in a box of 200 means that a maximum of 5 bolts will be defective. So, they are expecting that at least 5 defective bolts will be found in a box of 200 bolts. But it is known that 2% of such bolts are expected to be defective. So, we have to substitute the formula here. Probability of getting x less than or equal to 5 equals probability of having 0, probability of 1, probability of 2, probability of 3, probability of 4 and probability of 5. So, I substitute the value e to the power of minus 4 equals 0.0183. So, 0.0183 into 4 to the power of 0 divided by 0 factorial plus 0.0183 into the 4 to the power of 1 by 1 factorial, then into 4 square by 2 factorial into 4 cube by 3 factorial, 4 to the power of 4 by 4 factorial, 4 to the power of 5 by 5 factorial. So, I get the answer as 0.0183 into 1. Then into 4 into 16 into 64, 256 and 1024. So, this will be equal to 1 minus all this. So, when I add all this, I get 0.7845. So the probability of getting at most 5 volts will be, I have to minus this 1 minus 0.7845. So this will be equal to 0.2155. So the answer is 0.2155. This is the answer. That is, the chances of getting at most 5 defective bolts is 0.2155. Now we go to the next problem. So fit a Poisson distribution to the following data. Calculate the theoretical frequencies. So they have given us the x values, then they have given us the f values and the f of x. Now we have the probability of 0. So I write n into e to the power of minus m. So that will be equal to 200 into e to the power of minus 0.50. So when I do this e to the power of minus 0.50, I get 200 into 0.6065. That will be 121.3. Then n of probability of 1 will be equal to n into e to the power of minus m. That will be equal to 200 into Now we have a problem here. Fit a Poisson distribution to the following data and calculate the theoretical frequencies. So x equals 0, 1, 2, 3, 4 and the frequency is 153, 59, 14, 3 and 1. So total frequency equals 200. Now f of x, that is frequency into x, will be equal to fx equals 100. Now calculation of expected theoretical frequencies. Now how do we calculate the theoretical frequencies? Now I use this formula n of p into O. So if the occurrence is 0 or if there is the probability of not happening of an event, then n into e to the power of minus m. So we know that e to the power of m equals 0.50. So the value of e to the power of minus 0.50 equals 0.6065. So I substitute the values. So 200 into e to the power of 0.50. So when I substitute the value of e to the power of 0.50, I get 200 into 0.6065. So that is 121.3. Then again I make use of this 121.3 into this m of 1. So that is 0.50 divided by 1. Again I get 0.50. So this when I multiply, I get 60.65. So I make this of 60.65 into 0.50 divided by 2, I get 15.16. Then I make use of this 15.16 into 0.50 divided by 3. So the probability of occurrence is 3. So I divide it by 3, I get 2.53. Then 2.53 into 0.50 divided by 4, the occurrence is 4, then 0.36. So I plot all these values in the table here. So this is the Poisson distribution table. So when the probability of the event is 0, so the frequency is given as 153. So I write the observed frequency as 153, but the theoretical distribution shows that 121.30. Then when this is x is 1, the observed frequency, what is the observed frequency here? It is 59. So 59, so what is the value I am getting? 60.65. So I write the value as 60.65. Then when the observed frequency is 14, the value is 15.16. So when the observed frequency is 3, I get 2.53. So 1, it is 0.32. So now when I add all these theoretical distribution frequencies, it comes up to 199.6, which is approximately 200. So whatever frequency we got, the same frequency also we are getting when we do the theoretical distributions. Then next we'll go to normal distribution. Both binomial and Poisson distribution are based on discrete series, whereas normal distribution is widely used for continuous random variables. So continuous random variables means all those variables which can be sorted out between a class interval. So those variables we can find in this normal distribution. Now, in the normal distribution theory was discovered by an English mathematician D. Moore in 1731. It is also called as the Gaussian distribution due to the use for theory of accidental errors by Gaussian normal curve. It is a bell-shaped and symmetrical with two parameters, mean and standard deviation. The probability function of a random continuous variable is given by P of x equals 1 by standard deviation into root of 2 pi. So this will be equal to e to the power of minus half into x minus mean divided by standard deviation the whole square. So this symbol stands for mean and this rho means the standard deviation. Pi equals 22 by 7. The value of E equals 2.7183, which is a constant. Here the variable x is continuous and it is a normal variate. Now, the example of normal distribution are height and weight of students of a particular college. So, this normal distribution will make use of under these circumstances, that is height and weight of the students. So, there may be one student who is very tall and one student who is very short, and all the height and weight of the other students, they will come in between these tallest and the shortest student. So, that is what we call as the normal distribution, and the marks stored by students in the examination. So, the highest scorer may score 100 and the least scorer may score 0. So, all others will fall in between the 0 and 100. So, that we call it as the normal distribution. The intelligent quotient of a large group of students. So, one may be very highly intelligent, the other may be having a very low IQ. So, all others will fall in between these two. So, for all these kind of observations, we use the normal distribution. Then, normal distribution, when the values of both mean and standard deviation are assumed to be different, the normal distribution curve also assumes different shapes. So, when the mean and the standard deviation are different, then the normal deviation curve also takes a different shape. The number of trials n is very large here. See, for the Poisson distribution, the n was very small, but then in case of normal distribution, it will be very large. If you are having a survey of the population of India, then the population will be very large. So, P and Q are not very small. So, we can see that the success and failure rates are also will be very high. Now, if you look into the properties of normal distribution, the value of mean, median, mode are equal. So, all of them are equal. The skewness is equal to 0 and it has only one mode. The first quartile and that quartile are equidistant from the median or the mode. So, Q1 and Q2 are always equidistant from the mode and the normal curve is perfectly symmetrical. If you can see that it will always be in a bell shape and it will be symmetrical on both sides, and the normal distribution with mean 0 and standard deviation is 1. So, we have this. These are the properties of the normal distribution. Now, we will do one problem on this. The lifetime of a certain type of battery has a mean life of 4000 hours and the standard deviation is 50 hours. So, they have given us the mean. What is the mean here? 4000 hours. And what is the standard deviation? 50 hours. Assuming normality for the distribution of the lifetime of the battery, find the following. percentage batteries which have a lifetime of more than 350 hours, lifetime value in hours above which the best 25% of the batteries have their life, the proportion of batteries that have a lifetime between 300 to 500 hours. So, we have to work out this problem. So, we will first note down what is given here and then we will solve the problem. In this problem, they have given us the mean life is 4000 hours and standard deviation is 50 hours. So, the percentage batteries which have a lifetime of more than 350 hours. So, we have to work out this problem. Before writing down this, we will make a note of what is given here in the problem. So, they have given us the mean is equal to 400 and X. So, we have to find out all those batteries which will burn for 350 hours and they have also given us the standard deviation as 50. Now, we have to find Z equals X minus mean divided by standard deviation. So, this will be equal to 350 minus 400 divided by 50. So, this will be 50 minus 50 divided by 50, that is equal to 1. So, we have here the problem here is the lifetime of a certain type of battery has a mean life of 4000 hours and standard deviation is 50 hours. Assuming the normality for the distribution of the lifetime of the battery, find the following. The percentage batteries which have a lifetime of more than 350 hours, the lifetime value in hours above which the best 25% of the batteries have their life, and the proportion of batteries that have a lifetime between 300 and 500 hours. Now, we find the answer for this in the next one. So, here mean equals X bar equals 400 and X equals 350 hours, standard deviation is 50. So, I write Z equals X minus X bar divided by standard deviation. So, this will be 350 minus 400 divided by 50. So, minus 50 by 50, that is equal to minus 1 into Z value. So, that Z value is 0.3413. Now, the required probability will be equal to 0.5000 plus 0.3413, that is 0.8413. So, into 100 when we do, I get 84.13%. Then, second one is, what is the second one? The lifetime value in hours above which the best 25% of the batteries have their life. Now, the lifetime value in hours above which the best 25% have batteries have their life. So, Z value corresponding to 25%, that is 0.25 is 0.67. Now, I have the Z value 0.67 equals X minus 400 divided by 50. So, I get this as 33.5. So, X minus equals X minus 400 or X will be equal to 433.5. Next one. In C, the question is the proportion of batteries that have a lifetime between 300 and 500 hours. So, between 300 and 500, I have two Z values here. Z1 is between 300 minus 400 divided by 50. So, I get it as minus 20 into Z value is 0.4772. Z2 equals 500 minus 400 divided by 50. So, the answer is 2 and the value is 0.4772. So, when I add both Z1 and Z2, I get 0.9544 or 95%. Now, the next problem, the weekly wages of 1000 workmen are normally distribution with a mean of rupees 70 and standard deviation of rupees 5. Estimate the number of workers whose weekly wages will be between 70 and 72, 69 and 72, more than 75, less than 63, more than 80. So, we find the values here. Yes. In this problem, we have between 70 and 72. Estimate the number of workers whose weekly wages will be between rupees 70 and 72. So, I make use of the formula Z1 equals X minus X bar divided by standard deviation. So, the smallest number is 70. So, 70 minus 70 divided by 5, that is 0 into Z value, that is 0.0000, and Z2. So, 72 minus 70 by 5, that is Z value equals 0.1554. So, when I add both of this Z1 and Z2, I get the answer as 0.1554. Now, the required probability, how do I find the required number of workers? The probability into number of workers. Now, what is the probability? 0.1554 into 1000. So, I get 15.54 or 16 workers. So, around 16 workers, they are earning the wages between 70 and 72. Now, in the next case, between 69 and 72. In the second one, we have between 69 and 72. So, I know Z1 equals X minus X bar divided by mean. So, I have the mean here. What is the mean here? 70. So, 69 minus 70 divided by 5. So, that will be minus 1 divided by 5. Minus 2 into Z value 0. Now, here we have this between the probability of having the wages between 69 and 72. I take 69 minus 70 divided by 5. I get the answer as minus 1 divided by 5. So, minus 2 Z value means 0793. So, we have to find the values from the normal distribution table. So, I get the value of minus 2 as 0.0793. So, next is between 72 and 70, I get the value as 0.4. So, the Z value is 0.1554. Now, I add both of this, I get 0.2347. So, into number of workers, 1000. So, that will be 235 workers, they are drawing between 69 and 72. Then, for the third one, they are asking how many workers are drawing between 70 to 75 rupees. So, I get the Z value as 0.3413. So, first thing is I minus 0.5000 minus 0.3413. I get 0.1587 into 1000 or 159 workers. So, the same way I do for I calculate the Z value, then subtract it by 0.5000. So, I get the answer as 0808 into 1000. So, it becomes 81 workers. So, the Z value for 2 is 0.4772. So, minus 5000. So, 0.228 into 1000. So, 23 workers. So, we have come to the end of this session. Hope you have followed. Thank you.